Hi everyone, Zach here, and welcome to Lesson 11 of this series, Learning C++ by Making Games. In this video, we'll go over our math operators. This video is brought to you by my Patreon sponsors like Nemian Games and Archaic Methods. In this video, we'll go over arithmetic operators, including the modular operator, compound assignments, increment and decrementing variables, and we'll go over rational and logical operators and ternary operators. So, arithmetic operators are something you should be familiar with from basic math or maths, depending on if you prefer the British way of saying it. For example, you should be familiar with the plus sign, meaning addition, so 1 plus 1 equals 2. And the subtraction sign, meaning 2 minus 1 equals 1, and the multiplication sign, this case an asterisk or the star symbol, meaning multiplication, 3 times 2 is equal to 6, and the slash for division, so 4 divided by 2 is 2. Now, one you might not be familiar with is the modulus operator, the percentage sign. The modulus returns the remainder value. So 5 modulus 2 is equal to 1. Don't worry if you don't understand this yet. We'll go into more details on this in just a moment. So let's go over the modulus operator. The way to think about it is that it returns the remainder of a division. So if you don't remember long division, I do strongly recommend practicing long division. So if we use our example of 5 modular 2, what we are saying is 2 divided by 5. What's the remainder of that? Well, 2 goes into 5 2 times, and 2 times 2 is 4, so 4 minus 5 is 1. Because 2 does not go into 1, that is the remainder value. So when you get past basic long division like this, you might automatically go, this is 2.2, because 1 over 5 is 2. But if you remember your long division, you had remainders, you had a value there. That is what is returned by this operator. And this can be useful for determining odd versus even numbers. It can also be useful in determining if something is an integer or a float. Now, there is an alternative version of this operator for floats, and that operator is the fmod. It does the same thing for floating point numbers. Now, you may need to include a header, either the math.h header or the C math library header. And as I mentioned, this can be used to determine if a value is a floating value, so it has a decimal, or if it's an integer. And we'll explore how in just a moment. So let's talk about the fmod in a little bit more detail before we get into how we can use it to determine if something is a float or if something is an integer. The fmod requires 2 arguments. So you have fmod bracket, first argument, or the first variable, comma, the second argument, or the second variable. So x and y in this case. Now, we can use this to determine if something is an integer or a float if we multiply x by 10 and we set y to 10 as well. So that would be fmod x times 10, comma, so the x times 10 is the first argument, and then comma 10, our second argument. And let's take a look at an example. Let's say we have x is equal to 356. Now this is clearly an integer, but how does our system know? If we multiply it by 10, that makes it 3,560. So that's that first argument in our fmod. If we then put our second argument in of 10, and we take the modular of that, the remainder value is 0, and therefore it is an integer. Now, let's say we have a different value. Let's say that x is 35.6. When we multiply this by 10, we get a value of 356. If we take the modulus 10 of that, then we have a remainder value, and that remainder is 6. Meaning it's a float. So if the modular in this setup is 0, it's an integer. If it's anything else, it's a float. Now this might be helpful when we get to video 15 of this series. And if you're confused in video 15 when I put in one of the extra checks I didn't mention, well, come back to this video and check it out. Next, we have compound assignments. And compound assignments modify a value by performing a mathematical operation on that variable. So instead of having x equals y plus x, you could do x plus equals y, which would be the same thing. So let's take a look at a couple, or actually multiple ways of using this. So let's assume that x is 2 and y is 4. And if we use the operator plus equals, x plus equals y would be the same as 4 plus 2, and the result is 6. If we do minus equal, x minus equal y, it's 4 minus 2 is 2. We then have division as well. So slash equals, x slash equals is 4 divided by 2, or 2. And finally, we have multiplication. So asterisk equal, x asterisk equals 4 times 2 is 8. We can also increment and decrement values by 1. So incrementation is increasing a value by 1, and decrementing a value is decreasing that value by 1. You have already seen this in earlier videos when we were talking about loops. If you don't remember, go back and look at videos 8 and 9. And again, let's imagine we have x and y, where x is 2 and y is 4. So if we do x plus plus or plus plus x, what we were saying is 2 plus 1, which would be 3. And if we have y minus minus or minus minus y, we are saying 4 minus 1, which would also be 3. Next, we have rational and logical operators. And we'll start with rational operators. Again, these should be familiar from basic math. So a rational operator allows you to compare two expressions or variables. So let's say we want to say are two things equal to each other, and we're going to use x as 2 and y as 4 as before. And the operator for equal is a double equal sign. So x equal y means is x equal to y, and 2 is not equal to 4, so that would be a false statement. Next, we have not equals to, and that is exclamation mark equal sign. So x exclamation mark y is 2 not equal to 4, and that statement is true. 2 is not equal to 4. We have our less than. So x is less than y. 2 is less than 4. That is true. We also have our greater than. X is greater than y. 2 is greater than 4. That is false. We also have a way to say is something less than or equal to. And we can use this with the caret symbol equal sign. So x is less than or equal to y. 2 is less than or equal to 4. This would return a true value. We can also do is greater than or equal to. So x is greater than or equal to y. 2 is greater than or equal to 4, which is false. Next, we have our logical operators. And logical operators allow for us to make multiple comparisons. And there are two which we should be aware of. The first is the AND comparison. And this is done by using two ampersand or two AND symbols. And let's take a look at how this works. So let's say we have two variables, A and B. A is true, B is true. The result of A and B will also be true. Now let's say A is true, but B is false. A and B both need to be true. In this case, we would return a false because A is true and B is not. Likewise, if A is false while B is true, the result of A and B is still false because A is false. And of course, if they're both false, then the result will also be false. The other operator we need to consider is the OR operator, which is represented by two upright bars, not the broken ones that are on some keyboards. And let's think about this with the same setup of a variable A and B, where the result will be of A or B. So if A is true and B is true, the result of A or B is true. If the result of A is true but B is false, the result of A or B is still true. The result of A or B when A is false and B is true is also true. And in the only case where the result of A or B will be false is if both are false. So with A and B, both values have to be true to get a true result. In A or B, only one value has to be true for it to be true, but both values have to be false for it to be returned as a false. Next, we have ternary logic operators. And these allow for a comparison to be made and then a determination about what expression to evaluate or to use. So the way this is written out is you have your condition, a question mark, your true result, a colon symbol, and then your false result. So let's take a look at a couple of examples. So let's say we have 10 is equal to 7, and if that's true, we'll evaluate 1, and if that's false, we'll evaluate 2. So 10 is not equal to 7, that's false, we'll evaluate 2. Let's say we have is 10 equal to 7 plus 3. If it's true, then we'll evaluate 1. If it's false, then we'll evaluate 2. Well, 7 plus 3 is 10, so 10 is equal to 10. So this evaluates as true, we will use 1. If we say 10 is greater than or equal to 10, that's true, so again we'll evaluate 1. If we say 10 is less than or equal to 10, well, this is also true, they're equal to each other. So again, we'll evaluate 1. If we say 10 greater than 5, this is also true, so we evaluate 1. But if we say 10 is less than 5, this is false, so we'll evaluate 2. Now, you can have any sort of combination you want in here, and any sort of evaluation with any expressions on the true result or false result. You can use this to direct the flow of how a program works. If certain things are done, then go down one branch and follow that. If something else happens, go down the other branch. Alright, that brings us through all of the mathematical and logical operators we need to know to proceed with the rest of this series. We may cover some more ways to use these and some nuances and how to combine them together as this series goes on. But if you've enjoyed this video, make sure to hit that like button down below. And if you want to be here when we work on our random numbers and put our random number into our game, make sure to hit that subscribe and notify icon so you know when those videos are out. That said, consider becoming a Patreon supporter, and I look forward to seeing you in the next video, and I hope that you have a wonderful day.